Welcome back to the deep dive. So today we're looking up, way up. We're talking about the ultimate military strategy, the one thing that every general throughout history, from Sun Tzu to Napoleon, has obsessed over.
The high ground.
The high ground.
It's the oldest rule in the book. I mean, it's just geometry, really. If you're on the hill and your enemy's in the valley, you win.
You can see everything.
You can see everything, you can strike anywhere, and they have to fight gravity just to get to you.
Exactly. And in the modern world, there is no higher ground than orbit. I mean, logically, if you control space, you control the planet, right?
Right.
It feels inevitable.
You'd think so. And honestly, if you look at science fiction, you'd expect orbital battle stations by now. Lasers, dogfights.
X-Wings and Star Destroyers, yeah.
But the reality of space warfare is, well, it's a lot less pew-pew and a lot more Isaac Newton just ruining everyone's fun.
Newton really is the ultimate party pooper in the story.
He really is. So the mission for this deep dive is to figure out why, despite space being this huge strategic advantage, it hasn't turned into a literal battlefield. We've got a stack of sources here that'll take us through the physics, the history.
And some of this stuff is wild. We're talking rods from God, secret Soviet space cannons.
Oh, yeah. It's a mix of terrifying potential and just frustrating reality.
Okay, so let's start with the basics. The sci-fi image. Spaceships banking and firing turrets like it's World War II.
That's the movie version.
Yeah.
And it ignores the biggest hurdle, physics. Specifically, Newton's third law.
For every action, there is an equal and opposite reaction. I think I remember that from high school.
It's the law that keeps space, peaceful-ish. Think about it this way. On Earth, if you fire a heavy machine gun, you feel the recoil, right? The gun kicks back.
Sure, but you brace yourself. Your boots are on the ground.
Exactly. Friction holds you in place. The Earth absorbs that energy. But space is a vacuum. There's no air, no friction. So imagine you're on perfectly smooth ice, wearing roller skates, and you fire a shotgun. What happens?
The bullet goes one way, and I go flying backward the other way.
Precisely. Now scale that up to a satellite. You mount a cannon on it and fire. The recoil pushes the entire station. You aren't just shooting a bullet, you're basically turning your own weapon into a thruster.
So you pull the trigger to shoot the bad guy, and you accidentally knock your own station out of orbit.
You could send it tumbling, snap off your solar panels, or, even worse, deorbit it so it just burns up. All from firing your own weapon.
That feels like a significant design flaw.
A massive one. And the only way to fix it is to have reaction control thrusters firing at the exact same time to cancel out the recoil.
Which means you need fuel.
Lot of it. And getting fuel to orbit is the most expensive shipping cost. Well, in the universe, we're talking, what, $1 million per pound, historically? Stabilizing a space gun just becomes financially ruinous.
The accountant comes in and says, sorry, General, we can't afford the recoil.
Pretty much. And it's not just guns. Missiles have their own set of problems. Firing a missile from orbit down to Earth means it has to survive re-entry. And that generates extreme heat.
And conventional explosives don't like heat.
They really don't.
Yeah.
You'd need this heavy, expensive shielding to stop the bomb from just, cooking off before it even hits the ground.
So it's just cheaper and safer to launch from a submarine or a silo.
Much cheaper. However, there is one type of weapon where the cost might be justified.
We're talking about nuclear weapons.
Exactly. The nuclear nightmare.
Okay, let's unpack this. Why put a nuke in space? Is it just about having it hanging over the enemy's head?
It's about speed. Think about an ICBM. If Russia launches a nuke at the U.S., it travels in this high arc. It goes up, across the ocean, comes down. That takes about 41 minutes.
41 minutes. That's a window to react. To get on the phone, sound the sirens.
Right. But if you have a nuclear-armed satellite at, say, the altitude of the ISS, around 250 miles up, you're not waiting 40 minutes. You're looking at a strike time of maybe 15 minutes.
That cuts the reaction time by more than half.
And it gets worse. An ICBM launch has a huge rocket flare. Our satellites see that heat signature instantly. But an orbital nuke, it just uses a tiny thruster to deorbit. There's no massive flare.
It's a sneak attack. You could decapitate the enemy's leadership before they even know what's happening.
That's the terror of it. It breaks the whole concept of mutually assured destruction. So why haven't we done it? I know we have treaties, which we'll get to, but did anyone ever try it?
We didn't just try it. We tested it. And the results were shocking. We need to talk about Starfish Prime. Starfish Prime sounds like a sci-fi movie title, but it was a real U.S. military test.
July 9, 1962, height of the Cold War. The U.S. launched a Thor rocket from Johnston Island in the Pacific,
Yeah.
carrying a 1.4 megaton thermonuclear warhead.
For context, that is a massive bomb.
Huge.
Yeah.
And they detonated it 240 miles up in the vacuum of space.
Now, I think most of us picture a mushroom cloud, a huge roar, but in space.
Totally different. No air means no sound. It was silent. And no mushroom cloud. What observers saw was a perfect, silent sphere of light. It created this artificial aurora green and red ribbons of light that stretched for thousands of miles.
That sounds weirdly beautiful.
It was, until the lights went out in Hawaii.
Wait, Hawaii, that's what, 900 miles away?
900 miles.
Yeah.
And yet in Honolulu, streetlights blew out. Telephone systems failed. Burglar alarms just started going off everywhere.
Wow. From a silent explosion in space.
The EMP. The electromagnetic pulse. The scientists knew there would be some radiation, but they totally underestimated what happens when a high-altitude nuclear blast interacts with the Earth's magnetic field
So they basically turned the sky into a giant electrical circuit.
and it fried electronics on the ground. But here's the kicker, and this is why we don't put nukes in space.
Oh.
That radiation didn't just go away, it formed an artificial radiation belt around the Earth
It stayed there.
for months. And that belt started destroying satellites.
Who's that like?
Everyone's. It took out at least 6 satellites, including Telstar 1. And Telstar was a big deal. It was the first commercial communications satellite. We fried our own future of communication.
So the lesson of Starfish Prime is, if you detonate a nuke in space, you don't just hit your enemy, you blind yourself.
Exactly. It's a kamikaze move. You take out their grid, but you also take out your own eyes and ears. The weapon is too dangerous to the user.
Which I imagine helped lead to the legal shield we have today.
It certainly sped things up. The Outer Space Treaty of October 1967, signed by the U.S., the USSR, the U.K., most nations have signed it now.
And what's the core rule? No nukes in space.
That's the gist of it. It bans placing nuclear weapons or any other weapons of mass destruction WMDs in orbit. It's designed to stop that nuclear nightmare scenario.
Okay, so no nukes, but I'm looking at the fine print here. It doesn't say no weapons at all, does it?
That is the loophole. It explicitly bans WMDs. It does not ban conventional weapons, guns, lasers. Technically fair game.
And surely someone drove a truck through that loophole?
The Soviets did. In the 1970s, they launched the Almaz space stations. Publicly, they were research labs. In reality, military reconnaissance stations. And on one of them, they installed a gun.
A space gun.
An R-23M Kartek cannon, modified from an aircraft. They were terrified the Americans would try to dock with their station and capture it, so they armed it.
Did they? Did they ever fire it?
Once, as a test. But remember the recoil
A
problem.
roller skate problem, right?
They were so worried about the vibration ripping the station apart that they waited until the crew had left. Just before the station was set to deorbit, they fired the cannon remotely.
So they proved it worked, but it was too dangerous to use with people on board.
Precisely. It brings us back to that central theme. You can put weapons in space, but the costs, physical, financial, political, are usually just too high. But that hasn't stopped people from dreaming.
And this is where it gets really interesting. Because if you can't use nukes and guns are too messy, you use gravity.
Let's talk about rods from God.
Project Thor. It's the stuff of sci-fi nightmares, but the physics are frighteningly solid. The concept is simple, right? No explosives, just a very, very heavy stick.
A very heavy stick. The design calls for tungsten rods. Tungsten is key because it's incredibly dense and heat resistant. Imagine a telephone pole made of solid metal 20 feet long, a foot wide.
Then you just drop it.
You drop it from orbit. It has small fins for guidance, but no warhead. It's a kinetic bombardment weapon.
Walk me through the impact. What happens when that hits the Earth at orbital speed?
Well, gravity accelerates it. So the time it hits the ground, it's traveling at Mach 10. 10 times the speed of sound.
Wow.
The physics are simple. Force equals mass times acceleration. It hits and dumps all that kinetic energy instantly. The impact would have the force of a small tactical nuke. It could vaporize a city block. But, and this is the key, no fallout, no radiation.
It's a clean nuke.
In terms of radiation, yes. And because it's a solid rod moving at Mach 10, it can penetrate deep underground. It's the ultimate bunker buster.
So if this is possible, and it's legal under the treaty, why aren't they up there right now? Or are they?
The official answer is no. And the reason comes down to cost and game theory. First, lifting heavy tungsten rods to orbit is just exorbitantly expensive.
And the game theory part.
It's the prisoner's dilemma. These weapons are destabilizing. If the U.S. puts a rods from God platform up there, what do Russia and China do? They can't tell if that satellite is holding tungsten rods or nuclear warheads.
It looks the same on radar.
Exactly. So they have two choices. Build their own, triggering a massive arms race, or attack the U.S. platform before it can even come online.
It makes everyone trigger happy.
It does. It's too threatening. It looks like a first-strike weapon. So, paradoxically, the most powerful weapons are the ones nobody wants to build because they make the world less safe for everyone, including the person holding them.
A stalemate. But that doesn't mean the military isn't in space. I mean, we have a space force now.
We do. And other nations have their own space commands.
And when people hear Space Force, they imagine soldiers in zero-G with laser rifles. But the reality is a lot more boring.
It isn't Space Marines fighting aliens, no. The reality of the Space Force and space warfare right now is about information.
The eyes and ears.
Exactly. The real weapon is the satellite itself. Logistics and surveillance. Satellites let the military see enemy movements in real time. Cloud-penetrating radar can spot a tank column in a storm.
You mentioned North Korea earlier. We monitor their nuclear tests from space.
We do, but it's not just seeing, it's talking. Modern militaries run on GPS. A guided missile needs satellites to hit its target. A drone needs a satellite link. Secure comms go through space.
So without space, the modern military is what?
Blind, deaf, and dumb. The U.S. has, what, around 123 military satellites? If those go down, you lose GPS. Your artillery can't aim. You're back to using paper maps.
So the Space Force isn't there to shoot, it's there to protect the satellites from being shot. Or blinded.
Their job is to keep the lights on, because space is the ultimate high ground, not because you can drop rods from it, but because it lets you see everything on the ground.
It's interesting. We started this deep dive looking for super weapons, but it turns out the most dangerous thing is just being able to see.
Information is the deadliest weapon of all.
So, to summarize, the high ground is occupied, but it's a Cold War. No guns because of recoil, no nukes because of EMPs and treaties, and no kinetic rods because they're too expensive and destabilizing.
Right. We use the high ground for surveillance and logistics. It's a state of armed observation.
But I have to ask, how long does that hold?
That is the big question.
Because you mentioned cost being a major barrier, but we're living in the era of SpaceX, reusable rockets. The cost to get to orbit is dropping like a stone.
It is. And as the cost drops, the barriers to weaponization drop too.
So if it suddenly becomes cheap to put a tungsten rod in space, does the math change?
The physics barrier recoil, EMPs, that stays the same. Newton doesn't negotiate. But the economic barrier is crumbling. And history shows us one thing. Where humanity goes, conflict follows.
And treaties are just pieces of paper.
And paper burns. With private space enterprise and reusable rockets, the high ground is becoming more accessible than ever. The question isn't just can we build it anymore, it's will we choose not to?
A sobering thought. We're safe from space lasers for now, but maybe keep an eye on the sky.
Always.
That's it for this deep dive. Thanks for listening, and we'll see you on the next one.